In Lesson 3.1, we will be discussing exponential functions. In Video 3.1.3, our learning target is for students to evaluate, analyze, and graph exponential functions. In Example 3, we will be discussing graphing natural-based exponential functions. Exponential function with the natural base is base e. E is approximately 2.71. It's an irrational number similar to pi, and it's used often in real-world applications involving finance. Now, for part A, we're asked to use the graph of f of x equals e to the x to describe the transformation that results in g of x equals e to the 3x. We are then going to sketch the graph of the function. Okay, you can see that the graph's already provided here, but we do need to describe the transformation that results in g of x from f of x. So what am I doing to f of x to get g of x? What effect does that 3 in front of the x have on the graph? Because if we compare the two functions, f of x is my original function, or what's often called our parent function, and g of x is e to the 3x. The only thing different between these two functions is the 3 in front of the x. How does that affect our graph? Well, anytime we change something to the x, or so multiply x by something, or add something to x, or subtract something from x, that changes our graph horizontally because the x-axis runs horizontally. Now, horizontal transformations always have the opposite effect than you think they would. In this case, multiplying by 3 horizontally compresses the graph. So we can say g of x is horizontally compressed by a factor of 3. So I'll just do by times 3 or by a factor of 3. Now, if I wanted to graph both these functions, how I get the graph of this function, when we graph on our graphing calculator, we have y1 equals e to the x. And to get that value of e, if you press second and then ln on your calculator, it's on the very left-hand column, on the very left-hand side, about halfway down on your graphing calculator, you'll see a little e to the x above the ln button. That will give you this e. So if I hit second and then ln, you'll see this little e, which is approximately 2.71, and then we can raise that to the x power. I'm going to do the same thing for y2, except this time I'm going to say e raised to the 3x. And if I graph them on the same axes or same coordinate plane under a standard window, you will see a graph similar to what we have pictured here. Now, you can change your graph on your graphing calculator to make one line thicker than the other. So you could do like this y1, the parent function, as a normal line, and then you can make y2 a bold line by moving your cursor over to where this line is under y equals, and then if you use the enter key, you can select through several options to change the appearance of the line on your graph. In example 3, part B, we're asked to use the graph of f of x equals e to the x, so same parent function, and we are going to describe the transformation that results in h of x equals e raised to the negative x minus 1. We're then going to sketch the graph of this function. Okay, we already have the graph here. We want to describe the transformation comparing f of x, which is e to the x, and comparing g of x, h of x, take that back. H of x is equal to e raised to the negative x minus 1. Now, to describe this transformation, we know that anytime we take the parent function and subtract something or add something to it, that shifts the graph vertically. So the minus 1 is going to be shift down 1 unit. And the negative, changing the sign on the x-coordinate, actually reflects the graph over the y-axis. So anytime x changes sign, that's reflecting the graph over the y-axis. So we also reflect the function over the y-axis, and we shift down 1 unit. It doesn't matter what order you do these in. You can do these operations in whatever order you want. So you could take the original function, f of x, shift it down 1 unit, and then reflect over the y-axis if you wanted to. However you want to do that. It doesn't matter what order. You can do these two transformations in any order that you want. Okay, so we've described our transformation here. H of x is a shift down 1 and a reflection over the y-axis of f of x. Okay, so we're taking f of x and shifting it down 1 and then reflecting over the y-axis in order to get the graph of h of x. Now, on your graphing calculator, you can graph these two functions on a standard window. Again, in order to get base E, you have to use second, and then that ln button, which is on the far left-hand side of your graphing calculator. Right above it, you'll see e to the x, and that will allow you to get that base E, which is approximately 2.71. In example C, we're going to use the same parent function again, e to the x, natural base exponential function, and we're going to describe the transformation that results in j of x equals 2 times e to the x. Now, f of x equals e to the x, and j of x is 2 times e to the x. Anytime we multiply our parent function by a value bigger than 1, larger than 1, greater than 1, that vertically expands the graph. So we can say that j of x is a vertical expansion by a factor of 2 because we're multiplying by 2. Now, to graph these two functions, you can always graph the y function or the parent function in y1. You can graph this in y2 and use a standard window, and you can compare the two graphs. We can see that j of x is a vertical expansion because it moves up twice as quickly as the f of x function. Here you can see, if you want to compare in the table, that every point on f of x, the y-coordinates of those points are twice as big on the j of x function. So right here on f of x, I have a y-coordinate of 1. On the j of x function, that would be a y-coordinate of 2 times bigger. On the f of x function here, my y-coordinate is 3, and it would be double that on the j of x function. So at x equals 1, we would have a y-coordinate of 6. Okay, so if you look at that in your table, you can see that in your table that for each y value in f of x, your y values for j of x are twice as big. In the guided practice example 3, you're going to be asked to graph the function f of x equals e to the x and then describe the transformation that results in p of x equals e to the x plus 2. Okay, at this point, I want you to look at these two functions, decide on the transformation. We have 4 different options here, and then I would like you to submit your answer to this question. In example 3, guided practice part B, we're asked to sketch the graph of the function p of x equals e to the x plus 2. I would like you to go ahead and graph e to the x plus 2 on your graphing calculator along with the original function f of x, which was e to the x, right? Our parent function was e to the x. And I'm going to have you select A, B, C, or D, which graphs accurately portray f of x and p of x.